This is a short talk about orthogonal drawing, a type of drawing used in design and architecture, of which the image here shown is one example. Have a closer look at this, as this is actually the plan of your site. This video isn't a how-to guide, but is intended to give you an understanding of what orthogonal drawings are and why you'll need them. In the Middle Ages, architects did not draw whole buildings, and the notion of scale was completely unknown to them. Although in Gothic times, architecture was fundamentally a constructive practice, operating through well-established traditions, and the experience carried by masons of geometry and the rules applied could be applied directly onto the site. When building the most impressive cathedrals, there was no architectural drawings at hand, and the whole process was based on these experiences and working things out on site as part of the process of building. In fact, prior to the Renaissance, architectural drawings as we know them were incredibly rare. The Renaissance period saw the birth of architectural drawing, which came to define the new profession of the architect, whose role came to be found in the way whose role came to be defined by the need to find a way to represent architecture, a building or space, through something else, a drawing or a model. Here we can see Brunelleschi, one of the fathers of linear perspective, and Battisti in Florence, famed for the first ever perspective painting. Their developments led to our appreciation of pictorial graphics, being able to visualize something in 2D in a very similar way to how we see it in reality. These developments of drawing raise questions about architectural representations. How does the medium representing architecture inform the methods and processes of the discipline? Is it possible for any architectural design to be represented in its totality? What in architecture and design actually needs to be represented? And how can architectural ideas be given definition prior to being constructed? The answer to these questions is supposedly found in descriptive geometry, a graphical communication system concerned with describing space in a mathematical way, which allows for the representation of three-dimensional objects in 2 dimensions. Understanding descriptive geometry allowed for the development of a classification of drawing systems, all with different characteristics. This chart shows the various drawing systems and representational techniques available to us. Here, our focus will be on orthogonal drawings. Orthographic drawings are understood as multi-views, where the drawing information consists of different sides or elevations of the object, all seen at the same time, and all of which are needed to make sense of the drawing and the object described. This type of drawings do not represent how we see an object. They do not use perspective and have no sense of depth apart from showing when something sits behind something else. It achieves this by enforcing a system of parallel lines of sight from each side of the object, projected perpendicular to the picture plane. In fact, orthogonal means right-angled. This principle is easier to understand if we use the metaphor of a glass box, a principle that originates from Descartes. An image is the object. This sits within a glass box. Each surface or plane of the glass box represents the picture of each side of the object, front, back, right, left, top and bottom. What an orthogonal drawing does is unwrap the glass box so that each picture lies flat and can be seen, giving multiple views of the same object which are all in proportion to each other. When we say in proportion, we see that each face has a direct measured relationship to all the others. We can see here what this means in relation to a drawing of a house. One important difference is when we look at the picture of the house from the bottom, which is known as the ground plan, all One important difference is when we look at the picture of the bottom of the house, which is known as the ground plan. All pictures or projections that run horizontally are known as plans. And here we have a ground plan, which is described as the bottom, and also the roof plan, which is described as the top. Here you can see a ground plan sliced through a house. Note how the slice is taken from a height that engages with the important architectural features like the windows, just like the measurements you took when you're on your site survey. The plan doesn't just look at the floor. The different faces of the house are called elevations. If we were to slice through the house vertically, like slicing a loaf of bread, then it is called a section. Sections can be taken through any part of the building or object that would help to explain how it works as a building or an object. Sections can also reveal the relationships between the different parts of a building that might not be apparent in any other elevation or plan drawing.